Welcome, Dr. Saurabh Chandraker.
Namaste, sir. Thank you so
Nam-
much. Good evening, everyone.
I request all the participants kindly switch on your camera so that we can take photograph with Dr. Saurabh Chandraker. I request all the participants. Thank you. So I welcome you all in this. Dr. Mulli, can we start? Dr. Mulli?
Yes,
Am I
sir, we
audible?
can start. Yes, sir. Yes, sir.
Okay. So I welcome you all in the third day and fifth session of this faculty development program. It is my honor and privilege to introduce Dr. Saurabh Chandraker, speaker of today's session. Dr. Saurabh Chandraker graduated from the Department of Mechanical Engineering, Pandit Ravi Shankar Shukla University, Raipur, in the year 2008. After graduation, he completed his master's in mechanical engineering with specialization machine design from Chhattisgarh Swami Vivekanand Technical University, Bhilai, in 2011. Thereafter, he completed his Doctor of Philosophy from Department of Mechanical Engineering, National Institute of Technology, Rourkela, in the year 2016. He has also completed his 2 years postdoctoral fellowship in the Department of Mechanical Engineering at the Indian Institute of Technology, Delhi, in 2018. Presently, Dr. Chandraker is working as an assistant professor in the Department of Mechanical Engineering, National Institute of Technology, Karnataka, Surathkal. He has published more than 20 SCI papers and 14 Scopus Index conference proceedings. Currently, he is a principal investigator of 6 government-sponsored Department of Science and Technology and AICT-sponsored projects. His area of research are rotor dynamics, vibration, composites, alloys, tribology, solar and nanotechnology. I welcome you, sir, in this ATAL online 6 days faculty development program on clean energy and environment sustainability. Over to you.
Thank you, sir. I will take a few minutes to just share my PPT, sir. Give me a
Yes,
minute.
yes. Now, if participant wish to off their camera, they can. We have taken the photograph. Thank you for your cooperation.
Sir, is the PPT is visible to you all?
Yes, yes, visible.
So is it in
Yes, sir,
presentable
it's
mode?
visible.
Yes, yes,
And it
visible.
is in
Kindly make it full
presentable?
screen. Yes, yes.
Uh,
Kindly make it full screen.
yeah, I did it. Is it in presentable mode?
Yes, yes,
Yeah, full screen, na?
yes, yes.
Okay. So good evening, everyone. And I will just give a special thanks to our Department of Mechanical Engineering, Government College, Palmu, Jharkhand, for giving me an opportunity to present a small work, what I did it after joining here as a government project. Okay. So it is a great opportunity ATAL FDP, Government of India, has initiated for clean energy and environmental sustainability, as our Indian government has a vision to make a zero carbon footprint by 2050. So it's a very good initiative. By learning also, we can achieve few things. Okay. In similar fashion, actually, I have chosen this topic when Abhishek sir told me, can you give some, because I am from mechanical design. My most work is in mechanical design. So what I thought like that, okay, I will talk based on what I did it in my after PhD, after designing something, whatever I had made it. So how I want to give that something which I did it in a real time basis, not with a bookish thing. Okay. So hopefully you will enjoy. So that's why I have chosen a topic related to that. Whatever the challenges we are facing in renewable energy, and what will be the alternate solutions we can develop by means of our mechanical designs. Okay, maybe in this FDP you all are from energy background or thermal engineering. Maybe you did your MTech in thermal engineering, but mechanical we are, from our by birth or something like that. We are from core branches like basic mechanical, electrical, and something like that. Okay, so how to do that designing area? So we are at least good in CAD or something like that. So many ideas we can develop. Okay, that we can pursue in making a small changes to increase the quality of renewable energy. Okay, so that in that thought process, so I will tell you what happened and why I went to this and why I written this project and how I got it and how I completed. So all whole journey I will tell you about in this presentation. Okay. So as sir has introduced, my name as Dr. Saurabh, working as an assistant professor in Department of Mechanical Engineering. Okay, NITK Surathkal. Okay, so everybody knows we have basically many types of renewable energy around us, in which solar energy, biomass energy, geothermal energy, hydropower energy, wind energy. These are the basic core renewable energy from where we are extracting a large amount of power that can be used as in a household, power plants, and many things like that. Okay, basically, but in this presentation, mostly I have focused on what I did is changes, a mechanical changes in the solar energy system like that. Okay, so by means of mechanical design. Okay, I have not changed so much things in just like I'm not a thermal guy who will do who will or a material guy who will generate a new semiconductor or something like that. No, with mechanism how I can make a small changes to generate a good amount of renewable energy, that I will present in my work. Okay, so our focus same thing. I have written a project on wind energy also, but due to time constraint I have only focused what I have completed till now. Okay, so solar energy is a very good sector where most of the, if you see just like we are facing a lot of happenings in this area like that. Okay, just like government is pushing many state. Okay, you develop a power plant like that, 200 acres allocated, 300 acres, 400 acres, 1000 acres, 2000 acres has been many times you heard like that, that has been 16,000 acre has been given to Adani to develop our, oh my god, like that. Okay, so huge money involvement in solar energy. Okay, but what are the challenges if you see in for from a local guy to a business perspective? Okay, these are my economical things, just like how economical I am developing our solar plants like that. Okay, so that is a very important aspects. Technological things, what new technologies I can put it, because if you see India, what in India has been done is like that for last 10-15 years or 20 years. We purchase many solar panels or something like that from outside the country. We assemble here, and as a small MSME, we used to build solar plants and other things like that. But as a semiconductor wise, we are still lack in this area. But right now, government is pushing it. No, we are not to purchase from outside. We have to build our own. Okay, so that technology is also there. But I am not working, so I am not discussing too much about that technology. Okay, but little bit you can discuss. And informational like that, just like how China, Germany, European countries has been very good in transportation of energy from one place to another. So this type of information we are lacking, is still lacking like that. Okay, as an institutional wise, what as just like we all are in phase of all faculty development, we are working somewhere. Okay, so as a institutional, what challenges are like that? The main challenge is acceptance of renewable energy. hey man, we are getting powers continuously through thermal power plant. What is the use of this solar and all like that? Okay, many institutions, they don't want to adapt, but government is pushing it on. No, you have to go for your own solar energy. You can generate wind energy and all, and that can be utilized for your own buildings and other things. It will institution mostly, they give a lot of money to all the, just like MESCOM. I am at Karnataka. MESCOM is giving electricity. So a lot, huge bunch of power consumption is there, and we used to give a lot bunch of money for that. Okay, so institutional is pushing. No, you go for a renewable things like that. Then personal challenges are also there, because this all technologies are little bit costlier. What we get as a salary, and government is pushing again, you spend something and GST is there. So all these things makes little bit costlier for us for the acceptance of solar energy. Okay, that is one of the biggest challenge. Okay, and political is always there, so we can't go like that. Some say like that, okay, no, you, why you are doing, and other things like that, so we don't go on that political zone. But as a researcher, our main motive is to solve at least one problem statement. Okay, so when I was going through, when I started thinking like that, okay, what changes we can do and why it has been important like that. Okay, so most of the, actually before that slide, I want to show this slide first. Okay, so this is the if you see this slide, what you can find it out like that, that government has,
Saurabh,
yes, yeah,
sorry to interrupt. Slide is not changing. Right now, we are in the first slide only.
slide is not changing.
Yes.
uh
I think you have you shared your whole screen. Yes, now it is changing. Now
just wait.
this is the third slide.
Yeah, just wait for a minute, I will do it again. If it is not, I will share, stop presenting.
Entire screen you can share.
Entire screen share. So is it fine now? It is visible, sir?
Yes,
If I am
yes.
changing, if I am
Yes, sir.
changing,
Yes, yes. Yes,
if
yes,
I am
yes.
changing the slide, it is visible now. It's
Yes,
also
yes,
changing.
Yes, visible.
Yes.
Yeah. Okay, fine. Sorry for the inconvenience. Okay. So the thing is, I want to show this slide as a continuity, what I was talking about, many different problems, what I have shown you, economical, technological, informational, institutional, personal, and political changes like that. Okay. These were the challenges, what I was talking about. Okay. So what I saw, where the problem statement come to my mind when I was writing the project. Okay, so it is not like right now you what you are doing it. Okay, this is not my area, solar. Okay, but I write the where I find it out. Okay, as a design person, I can do something better in this. Okay, so when I was from I have been living in Chhattisgarh for a few months like that, and I was traveling from Durg to just like Raipur area. Okay, so in that some area, it has been allocated for solar plant. Okay, on the left side of when you go from Durg to Raipur or something like that. Even you have also encountered like that. Okay, so when I saw like that, I want to purchase a small land nearby myself. Okay, so it was become very costly. And when I am passing from the highway, okay, and the government has allocated the government land itself for solar plants like that. Okay, so huge, almost around 20-30 acres they have allocated for solar plant like that. Okay, small area. What thought like that? It's a highway, pure. It's a national highway. Okay, it's a central highway like that, national highway between all Nagpur, Bombay, Kolkata. This route is there. Okay, beside that, government land is there, and 20 acre has been allocated for establishing solar panel. It is not harm because energy has been generated. But the problem, what I thought like that, if you see the whole country, each and every country is fighting for what? We are fighting for land acquisition of one country to another, because population is adapting continuously. It is not like that is stopping it somewhere like that. Okay, so we need land, and if you utilize land such like, just like if you see Okay, if you see this few areas like that, Badla Solar Park, okay, that Pagwada Solar Park, okay, from Jodhpur, Tumkur, Anantpur, Andhra Pradesh, Gujarat, Kurnool, Andhra Pradesh, okay, you can find it out 56 kilometer square area. Matlab, this much area has been allocated for solar plant, okay. 30,000 acre has been allocated in Karnataka to develop a solar plant like that. Okay. And if you see here, 6,000 acres. Okay. And many more has been allocated for all this work like that. Okay. 6,000 acre, 24 acre. Can you imagine in nearby future, our population will rise so exponentially? All this sustainability word will be visible in our lifetime like that. It is not like that. Okay. So, and it does not look monotonous. Na? Every time you see a rectangular panel in your home, okay, even acceptability as a personal choice. What is the challenge? What is the challenge like that? Somebody tells you government right now, if you know, the government has a scheme of just like you install your solar panel, your electricity bill will be totally zero like that. They have a plan like that, and they are giving subsidies also for that. Okay, Pradhan Mantri Solar Yojana and all like that is there for Grih Yojana like that, electricity. Okay, so it's a very good initiative. But what about acceptance? Right now, I am getting 400. Even government is subsidizing few shoot like 200 units and all. We will give subsidize or like that. So who will change? I don't want to change it. I am getting 800 monthly electricity bill or 2,000, not more than that. So why should I push a 3 kilowatt and I will put around 3 lakhs for that? And even government is giving subsidy about 80,000. Why should I put? Because why I don't want to put it? One thing is extra money you are putting it. Not only for at least 25 years you will get free electricity. Okay, but the thing is, one more thing which comes into our mind is we built our home in just like 1,000 square feet or something like that. And in the top floor we mostly use the place for what? Some dry things. We used to, every time we have to make some stuffs and we want to make it dry like that. Okay, papad and other stuffs, because I am Chhattisgarhi, so bari and all we used to put it, and we used to dry it in our that area. And if we put solar panel, again my area has been lost for 3 kilowatt. Okay, and if you have a more power consumption, it will take more area like that. So what problem statement I got it like that? Area is where I can work it on. Okay, can I do some innovation so that I can make the utilization of space in a compact way like that? Okay, so that was my main motive. When I was facing the same problem, I want to install a 3 kilowatt in my home. Oh, what man, this area, whole area, my child will play, everything I lost. Okay, then that phase was not there. Okay, so I thought like that, okay, let's build something like that. Okay, and even the efficiency, in the side of efficiency, if you see this traditional solar panels, those who are just inclined in certain angle, they have only detect the radiation at certain time period. Let's suppose it will be time from 11 to, let's suppose, 4 or something like that. For that 5 hours or 6 hour time period only, they used to give you a radiation or conversion of energy happens like that. Again, the efficiency is about very less, 6, 7, 8% of that like that. So that is one area, one problem statement we can get it. Another problem statement, I can find it out like that. Okay, one is monotonous feel like that. Okay, why this only rectangular plate? What is the very monotonous shape and all like that? Another thing is, uh, can I make the energy efficiency? Can I increase to 7 to 8% energy? What I am getting it as an actual? Can I increase it little bit more till 16, 17% or 20, 21% like that? So can I make some dynamic or some mechanical changes in that itself, and I can make some involvement and do the energy efficient system like that? Okay. So then I have to go, what is the working principle behind that? Okay, then I was learning like that. Okay, again, one more problem statement. One problem statement, I also got it. What was that problem? I find it out. Every time when you install your solar panel at one certain angle or something like that, wind will come, dust will come. Okay, it will accumulate it over the solar panel. What? Every 15 days you have to clean the solar panel. You have to just go to the rooftop, you have to clean, then again your efficiency. Otherwise, every 15 days you will find out that your solar energy has been decreasing, depleting like that. For what purpose you have purchased, but it has not solving your problem like that. Okay, but one thing is very good, you can go for solar panel in your house because government is providing you a good facility like that. Just like there are three ways of energy transformation, no? Just like you can use it as a inverter, just like offline grid like that. Okay, the second one is in a hybrid model, and a third one is an online model like that. Okay, so hybrid is like that, you can use it whatever the energy you want to use it, otherwise you can sell the remaining energy to the government. Okay, but many government is supporting, but many government is having some problem in their transformer or something like that, so they don't allow you. But third one is online. Online like that, you can sell whatever the thing is. Government is giving you money for that. Okay, so that is a very good initiative. And in if just like we used to say, now a drop by drop fills the vessel like that. So whatever drop by drop, if individual person starts uh, capitalizing all this benefits from government and install solar panel, we have a lot of area, we can develop a good not, we don't require much big solar plants, but with small steps, everybody can everyone have their own solar panel, and we can sell this electricity to the government also, we can earn also by giving some small space for that. Okay, so it's a very good initiative. Okay, so when my problem was little bit different because I have a small area, so little bit. So I thought like that, let's do some innovation in that design like that. Okay, why only rectangular? Or I have also inspired because somebody did in Austria. Okay, in Austria, one Austrian company, what they thought like that, okay, can I imitate some bio-inspired anything like that? Okay, so they imitate the same thing from, they taken a concept from what? Sunflower. What the sunflower do like that? Wherever the sun goes, the sunflower, the flower itself will also track that solar radiation, and it will band it from where it travels like that. It may be whatever. Okay. So if you see this figure like that, if you able to see this figure like that, there it tells you like that the azimuth angle where how the earths rotate, or all the rising of sun happens, and due to the rotation of earth and the shape of the earth, the polar moment and other things, how we used to put our solar panel at certain angle like that. Okay, so that initially you can feel like that. Okay, as when I was thinking, when I started, hey man, sun is always there, can I put it in the horizontal way like that? That is the best way. Why every time? But I learned, and after that I understood like that. Okay, why we are not putting a horizontal solar panel like that? Okay, there are many disadvantages in that. With the sunlight will not completely come to that panels. So we used to put it in some angle, tilted angle like that. Okay, so again, one tilted angle, space, many problem statements are there. So when the sun moves from here to here like that, let's suppose this and this like that, oh, so it will start tracking in this direction, the radiation will go like that. Okay, after certain time period, just like I told you, from 11 to around 4 or 5 like that. Okay, so in between, if you see here, when it reaches here or something, again after 4 p.m. we don't have a radiation which is projecting on that solar panel. Okay, and for your, if you know, if you are working in solar panel, you know the temperature has plays a vital role in the energy generation like that. Okay, If we think like that, more and more radiation, in very hot summer, we will get more energy. No, this is our misconception like that. Okay. As the temperature raises, the semiconductor also loses its efficiency. Okay, we have noticed, and we have now everything, and then in literature also it tells like that. If the heat of that solar panel increases, immediately your efficiency will also go up. So when you put your solar panel for certain time period where 11 to 4 you will get a maximum radiation and your power generation, that is our main myth like that. Okay, where we get the maximum when the temperature is normal in between 35 degrees centigrade or something like that, and radiation is also good, but temperature is like just like you have to throw out the temperature from the panel itself. Okay, so then only you will get a maximum efficiency, or you can extract a maximum efficiency from that solar panel. Okay, so that is the concept like that. I where I can see like that a flat panel is not recommended. Okay, inclined panel, what has disadvantages? I told you many disadvantages. It means in my perspective it has disadvantage. Okay, but when you go for a large solar plant like that, that government is doing it like that, so they are keeping manpowers also to clean every day. If you see the person, the crane is if you see is cleaning like that. Okay, so there are you have money investment also to regularize cleaning, to check how it has been involved or something like that. Okay, so few challenges what I feel like that, same I have reported here like that, just like installation space. You see how much area it has been taken like that. So it has installation space. So if you are keeping all the solar panel in your home and house, like okay, but when your government has doing the solar plant establishing, it will take a huge land. That what I have shown you as a, and these are our government reports, which is directly I have taken from the government websites. Okay, the shape of solar panel, mostly monotonous rectangular shape. I used to get it like that. No innovation from last 20 years like that. Okay. Only Austrian company has did it. And I also get inspiration from them also. Okay. Then what a convertible shape. There is no convert like that. Many of them right now, I will show you, just like they are tilting like this from east to west. Okay. There is some motion. I can generate it like that. Okay. Then panel type is you can use monocrystalline and polycrystalline. You can use anything, but I am not in good enough in telling you about the exact material side. So you can choose any monocrystalline and polycrystalline, depends on your activity like that. Okay. Then panel design is mostly, if you see, all are static. You keep putting the panels side by side like that. Okay. Then what it comes in our mind like that, percentage of the sun radiation exposed. If you think like that, no, sun will rise and it will only get in this direction like that. What happens when sun will here like that? Okay, the radiation will goes in opposite direction like that. Okay, so drastically reduction of radiations. Okay, we don't capture too much because our main capturing is in between morning. It was very good. 8 to 11 we get I will show you, we get a very good efficiency during 8 to 10 or something like that. And once the temperature raises, definitely the decrement also happens. Yeah, radiation is there, everything is there, but even we got a decremental in that. Okay, so aesthetic, ये तो है ही नहीं बिल्कुल भी. I don't feel like that any aesthetic thing is in any for lot so many years. There is no aesthetic thing. Only rectangular panels are like that. So can we make it from bio-inspired thing? Can we make it little bit aesthetic also? That is one of the problem statement we can choose it for as a design engineer. Can I make something new? Okay, then as a safety point of view, if you see rooftop panel may create risk in house fire like that. Sometime transformation happens, it may cost you a little bit more if there is a difference in voltage from online offline, something happen, may create, that is one another problem. Then you can tell what you have developed, it might be again same problem like that. No, we have taken care of that switching and all like that in that solar panel. Okay, so accumulated sediments like that. It means whenever dust flow every day to day, you will find it out in regular basis. If you don't clean your solar panel, that is the biggest challenge in solar plants. Okay, that due to dusting and all, the efficiency drastically reduces. Okay, if it is giving 8 or 9%, it will drastically half of that efficiency it is giving like that. Okay, so efficiency, I have talked it much about it. Okay, so what are the alternate solution till now which is present in our environment like that? Okay, and what's going on in nearby future if you want to jump and you want to develop some new technologies like that? What many peoples are doing it like that? Okay, so if you see Tata Power, Solar and Dell International Services both have joined hands to hand, and they have built a building in Bangalore which can produce itself 120 kilowatt, and they made the building in such a way that in their side areas, in the side of that wall, okay, so wall they are building solar panels and utilizing the solar energy for their building purposes like that. Okay, so that is another way where giants will come and they can make the building itself like walls are of solar panels like that. Okay, another research what is going on as an alternate solution to rectify all the challenges what I told you in verbally like that. Okay, many challenges what I have told of all the traditional solar plants like that. Okay, so another thing is you can produce what are roof tiles. Okay, roof tiles are what is a very good initiation, but still it has to come, not in India, but in many of the those who are living in if you see feel like that wooden houses and other things, there you can find it out. This type of tiles are now using in European countries like that. Okay, their panels itself come up with the solar panel, and the connections with all tiles they are generating parallel and series way. They are generating self-sustainable houses like that. Okay, so this is one area I have explored small, but yes, as a design engineer, the panels are straight, nothing more than. Only thing is we have to design the tiles in such a way that we can make our house sustainable like that. Okay, that will be our main target point of view. We have tried it, but still we have not got success in a good way like that. Okay, so another what government has been approaching like that. Okay, just like if you see this figure like that, if you see this figure, what you can find it like that. Now land war is there. Now after some time there will be a ocean war will also be there, because ocean and the dead sea water rivers are a very good place where you can keep your solar panels. Okay, so first Konkan, Maharashtra installed a 100 kilowatt pilot project. That okay, many of the other European countries they are doing well in generating an alternate solution in the solar technologies like that. So they are installing the same solar panel, but with the help of some bellows and nearby below, they will floated solar panel type of structure they are developing like that. Okay, so here what was the major problem that what they are facing is corrosion. Okay, corrosion is that major problem that what we are facing in this area, but it's a very good alternative solution, because here not only solar panels but the wind energy also we used to take it. So combination of wind and solar we used to do it in this type of regions like that. Okay, where the wind is also there and the water is not too much vibrant or so much float is there like that. Okay, so there we are using both like that, wind energy and solar energy simultaneously. Okay, so and then another is what if you see in 2020 Camry in Bengal, CSIR Camry has developed their okay, let's develop a tree type of a structure like that. Okay, so here you see still the panels are in same shape, same thing. Now only thing what they innovated is like that. Okay, at least I can use this space, the land space for walking, that is above. I can walk it here. Okay, I can move it This is not interrupting my main area like that. Now you feel like that this much solar panel, if I install in land, how much land has been accumulated, and I will not get a good things also like that. Okay. So that is some innovation area where design plays a vital role, mechanical design. Okay, where as per the problem statement, can a design engineer can small changes, make a small changes, and you will get a maximum results. That is the main thing like that. Okay, so Camry did it in a static way, but okay, one axis, but they have solved a small problem of land like that. Can okay, no problem, we can do it like that. Okay, so they have built it like that. Now, another innovation, what they are doing is just like a few of the institutional type of, for long days, many solar tracking devices has already been developed like that. Okay, right now. So right now, if you see, this is the single axis. If you see single axis solar track, nothing, same panel, same method, everything, but here they used to change it. They used to put one motor or something like that, and it has been controlly they can put one LDR circuit and something like that, and it tracks the solar panel where it is going on, and based on that this rectangular panel used to move it in this and this direction like that. Okay, so it is like that single axis, I can tell it will not be a multi-axis tracking system like that, but okay, we can do as a our BTech projects and other things like that with LDR circuit and all like that. Okay, it is visible enough to do it, and definitely the power efficiency will be quite higher as compared to the traditional. When I'm saying traditional, it means a fixed technology what we are using. Okay, and this little bit, okay, this is what they have developed manually. You have to build this setup like that. Here, if you see, the protector is there as per the maximum radiation. After 1 hour, somebody is going to that, and manually it is also you can do it. And with, if you keep one motor, you can do and make the changes of changing a small things like that. Okay, we can change the solar panel from where the sun has been tracking it out. Okay, it is not automatic, no LDR and other things like that, but okay, we can do it manually also. Okay, this is an Austrian innovation with a inspired from which sunflower. Okay, so they have developed based on their sunflower smart solar, smart solar sunflower like that. Even their name itself, and many of you have seen videos, many of you have already seen like that this type of panels are available in the market, and this is one of the biggest inspiration for me also. Okay, I can think in such a way so that I can reduce many spaces like that. Okay, so it's a very good Austrian company like that, and they have developed. Okay, even the China has also developed, but whatever China has developed, that much success we have also got it. Okay, so and later on I will show you. So motivation, when you write your project or something, just like all this what I have shown you, without funds we can't do anything like that. Okay, so fund is very important. So your motivation of doing it is very clear, crystal clear, and it will reflect to the government of India that what you are trying to do it. Okay, so based on our whatever the problem statement I showed you, okay, based on that what has been presented till now as a literature review or whatever the products available in India, I have shown you like that. Okay, so can I make it eco-friendly power generation system using solar that will be renewable and green? That is our biggest motivation. Okay, the main motivation of the proposed design is to reduce the space. Okay, Camry is also doing the space reduction, but still it is a static one. Again, oh, space, it's open, but I can't use the above area like that. Okay, so it is a static one. Okay, so can I make it little bit origami structure or something like that, convertible mechanism, so that as I want, when the radiation is there, I can use it. If it is not there, it will close. The energy is there, I can utilize it. I can use the space also. That will be a biggest motivation. The third motivation was come to from our mind is like that. The new proposed design will be expanding the qualities like beautification. Was monotonous na, whenever you go to your rooftop and you see, hey man, this rectangular panel is taking my space, and it is not giving me a good look. But if you install a smart sunflower or type of thing, many of person will come and see, oh man, what engineering you did it, what a beautiful design you have purchased, like that. Okay, so everyone wants a beautification things that been put in our home, like that. Okay, so one motivation is beautification, also convertible and automation. Okay, that is one factor, that no, I don't want to go and clean the dust of that panels and every time, okay, after 15 days or something like that. Okay, so automation should be there. So, and dust resistant and all that can be taken care, so that the efficiency will be what, for what purpose you have installed, that will be successfully getting you. Okay, so that will be a main motive of any person, like that, when they install the. And the another thing is, whatever the decrement in the power efficiency can be increases by at least twice of it. Okay, that will be the biggest motivation. Whenever you want your solar project, they will see, okay, what increment you are doing it, like that. Okay, so when I presented this project, I have only mathematical calculations, not as a physical experimental data, like that. Okay, but they convinced by seeing my mathematics and all, like, okay, you are saying it might be possible thing, like that, so they given funds. Okay, so initially when I started, so as a mechanical design engineer, raw something I made it. Okay, I thought like I will do this, many things I have presented in my like that. Okay, then I thought like, okay, let's, the system will go inside, it will buried, when the sun will come, this will open, just like when you see this, which what I have presented, like that. Okay, and this is feasible because human brain is what, like that, they can dream bigs. Okay, but it feasible or not, it will take time for the innovation, like that. Okay, so when I started my project, I thought like that, okay, it may be buried inside the yeah, and when morning it will open, just like if you see, this will open, then the next step, the panel will goes like this, it will open, and after this it will, all the petals will open in such a way, okay, like this, and after sunset immediately it will go to the box, like that, and the box will close, and the whole area will be utilized as a ground area, like that. Okay, so that was my biggest motivation when I was trying to do this solar project, like that. Okay, this was the mechanism which I thought like that, okay, I will put some screw there, some riveted joint there, and opening and closing mechanism. I have what, from there I inspired and I develop our own mechanism and other things, like that. Okay, but बोलना सोचना, dreams, what you say and what you dream, both are totally different. I was dream for a major thing changes, like that. Okay, but when I went to a ground reality, uh, when fund came and when I start my journey, like that. Okay, the major problem was like that, no one even agreed me to give me a solar panel of this shape. This is like petal shape, na? If you see, my panels are like petal shape. Okay, so it is arc type of things, but most of the panels, they are making only rectangular things. Nobody wants to even touch it. Okay, they told me like that, what is your order number? I said 8 panels or something. No, sir, I can't do it. Even I called to Adani, I called to many solar other Wari, other things where actually they have a system, they can change the solar panel, but they don't agree. And really, as a business perspective, I will also, if I am a businessman, I will not agree for the research and R&D. Why, if everything is going smoothly, why should I change my system and I can develop something for you 8 panels or like that? Okay, so these are the problem which I faced during my this completion of that project. Okay, so immediately what we have discovered, okay, these are the some challenges, loads and other things, panel loads and all these are challenges, like that. Okay, so I will discuss when I will show you something like that. Okay, so this is the mathematical calculation which I showed it for the comparison point of view, like that. What will be happen if I use the solar same traditional rectangular type panels? So what will be the length, area, width, everything I have calculated it. And whatever the smart flower which is existing in Austrian company has made it, their data I took it, and I can calculate the power output of that. Okay, so it is like that. If you see, this is the power output for what rectangular panels, and the cost effectiveness. Okay, that also we have discovered like that. Okay, so if you see for 3 kilowatt per hour, okay, same size, same something like that. Okay, what 3 lakh, 3 lakh, we can develop our traditional solar plant. Okay, very good. Traditional is very cheap. Within 3 lakhs, 3 kilowatt is feasible enough. But when you go and purchase 3 kilowatt of smart flower from Austria, it is costing me around 38 lakhs. Okay, without an export charges. So when you put your export and other percentage all, it reaches to 45 lakhs like that. Okay, so if I say a person, please Abhishek sir, you can install 3 kilowatt. So I have designed it. Is it not feasible? Look, yeah, even Ambani will also scold me like that. For 3 kilowatt, you are charging me 45 lakh. Why I will purchase, man? Like that. Okay, so many big people also they will not agree in an Indian condition like that. But I will tell you, for European countries, it's quite cheaper for them. Okay, because what research has been done in that part now, it's worthy to give 35 lakhs because they give 25 years warranty for that. Okay, warranty and guarantee that nothing will happen to your solar panels and other things like that. Okay, so that confidence, if I purchase this rectangular panel, they will give me 2 or 3 years. Okay, you go, I am not worried it will work or not. It's your problem, man. Once you purchase, nothing I will be worried about it. Even no government will also not take a part on that. So that's the thing is, if you develop something, develop in such a way, you give your confidence to the foremost person that, okay, whatever I am developing, it is a well established thing and it will give you a warranty. You have not to worry about anything like that for less 25, 30 years like that. Okay, then the cost is worthy, but the cost is so high just because they have sold not too much, but okay, in European country many of the big shots are purchasing like that. Okay, so I have shown also the efficiency part. If you see the efficiency part of, just like if something which is traditional or stationary static one, okay, it will generate up to 18, just like for this much. The sun is, the time is from just like 6 a.m. to till 6 p.m. or 7 p.m. like that, sunsets like that. So this has been, I have taken it from uh, energy table from one literature review. Okay, you see like that how the sun radiations and other things travels like that, or what you got it from day to evening like that. Okay, so when you put it for the calculation of a static one, you usually used to get it for that range is about 18% like that. Okay, and mostly the average when you do it for different hours like that, 25 kilowatt whatever the generation is there, based on that, if you do the calculation, the average efficiency is coming around 16% of that. Okay, 16% like that. Okay, but if you calculate the same for different time zones for this, whatever the smart flower I've shown you for Austrian company, okay, because that was only one reference for me, so I did the calculation and everything on based on that. So there you can see the percentage has been increased from this and this. If you calculate the average percentage, you will find it out like that, at least increment of 5%. And in solar sector, 5% is quite good number. I can tell you, 5 to 6%, 7%. If you increase the efficiency of anything, it's a very quite good number. Then you can tell, sir, but the cost is there. Yes, cost is always be associated with new technologies. Always be there. but I am not saying we can't reduce it. That's why our motivate our we are here like that. Okay, we have developed. Okay, so if you see the cost wise also, how much kilowatt has been generated, what will the cost, based on that I have also given you the everything like that, not only with panel wise but also with a cost wide calculation. Then somebody will accept, okay, he is giving each and every data, he is not lying to me. Okay, because if they are giving their hard earned money, they should know each and everything like that. Okay, then I showed my novelty in that. Okay, what is the novelty of doing this task like that? Okay, so the most important thing is I'm not with the incremental of 5 to 6%, 7% increment in the efficiency. I'm also giving you a good new gear based mechanism. Okay, it may be work for petal flowers, you can mimic it for different mechanisms also. If you put your gearbox, but if you put different mechanism in that also, it will work. Okay, so that was the main motive. So we are in the process of patenting it, our new other shapes also. That also we can say like that we have developed in this time period zone like that. Okay, we are improvising the new model. That is our during that project it was our main goal. But why I have written futuristic? Aaj, it means today, or by tomorrow, or some day will come. Definitely, you will find it out. The lands will be there, solar panels will be installed. But just like if you see some stadiums now, for till here, daytime, it has been used as stadium, but after night, it can be used for certain other purposes. So, in same way, my thought process was like that when we make our solar power plant like that, for some morning time it will extract the solar radiation, we generate electricity, but after certain time it will go down, our land can be used for different purposes. That is our main motive. Okay, so we will fulfill nearby future, because at least the upper part we have completed. Now the below part that we are have to be developed like that. Okay, so our we have seen by doing this 30 to 40% approximate increment in the energy side. Okay, and as our solar panel sells more and more, okay, what cost we had made it, I will show you, I will tell you at the end, and what cost we had made it, our prototype. Okay, so definitely it will be affordable to the common people. That I will promise like that. Even the production will be large, we can come up with reduced price like that. Okay, so in the conclusion, like these are my near to the last slides like that. So if you see the conclusions like that, we have developed a prototype of smart flower solar panels. We have increased the efficiency, okay, till 30 to 40% approximate like that. Okay, then we are saying like that we will show you a prototype that feels you okay. Till now nobody has done it, but we have achieved it. That is our biggest conclusion in that remarks like that. Okay, so these are just like uh, area where we can utilize it mostly. Okay, in household, just like for charging station, for airport beautification and charging, like most of them right now, many airports are totally solar based like that. In gardens, okay, individual houses also, in solar plants also we can utilize it. Okay, then I can show you a small video for that. That like this is the innovative smart for Indian condition what we have built it like that. Okay, so if you see just like I have showed you the glimpse of it, that how it looks like, what we have developed, how we wanted to install it for institutional point of view, so that feel you can take it like that. Okay, so these are my mechanical parts. Now, not but list. This will be my last slide. Okay, then I will end my lecture and we'll go for Okay, so what we can see is like that. Let's play it. Okay, so this is the product which I am revealing in front of you. Till now, I have not posted anywhere in front of all you as an audience. I am revealing our this new product in front of you. So this is my first time I am showing this product to our whole audience. So in the morning, it opens like this. In daytime, it is tracking the solar panel. If you are able to see, okay, the whole day it tracks like that. It has been installed in our top floor right now for testing. Right now, it is in a testing phase. Okay, and this is the panel what we had made it. Okay, with lot of efforts. The company which I helped me, you will next lecture is of that person only. In Cube Research R&D, in Cube R&D and research and consultancy, they have helped me a lot in manufacturing this. Okay, next session from 7:30 you will heard the person who helped me in that. Okay, and during evening this will be the shutdown motion. Okay, so are you able to see that how much area has been taken when you are putting a traditional solar panel, and this innovation will how much space has been taken by this one. Okay, so what about the cost and in the research? What if somebody asks me like that? So we got a good amount of fund from DST, but we have asked this for re-engineering design. Okay, but even Austrian company, they have not given us in that amount like that. So we have returned that money to DST, but we have developed this under 25 lakhs. Okay, R&D cost. So R&D cost and the product cost will always be differ. Okay, so we some money we have put it, some InCube has put it, software development, everything we did it indigenously, not from any other. We have did it in our in-house. Okay, so this ends, and I thank you. A special thanks to Abhishek Sharma sir, Dr. Abhishek Sharma sir, and his team for giving me opportunity. And in front of you, I am presenting this. And I will also thanks the Mechanical Engineering Department, Palmu, Jharkhand. Okay, so I will end my presentation. So thank you very much, and question and session. If you have any doubts or something you want to ask, please. Abhishek Sharma sir, are you here?
Sir, I am Murli Manohar,
Yes,
assistant
Murli.
professor.
Hello. Good
Yeah,
evening.
fine. Good evening, sir. Sir, perhaps Abhishek Sharma, sir, facing some technical issue to
Okay, okay.
join here.
No problem. No
And
problem, sir.
okay, sir. So I am handling this time.
Yeah,
Uh,
Murli sir. No problem, sir.
any
Tell me.
any question from
Sir,
audience side?
hello,
Yeah,
sir.
sir.
Sir, I want to
Many
ask
questions.
one question, sir.
Yeah.
Yes. Can I
Yes,
know
good
your
evening, sir.
name, sir? Good evening, sir.
Sir, Nitesh Singh Rajput, sir.
Okay, Nitesh. Please.
Sir, as you are design engineer and you are designing solar panels and you are into it,
Yes.
sir,
Yes.
and you are saying that the solar panels, the efficiency it decreases with the increase in temperature. So,
Yes.
sir, I
That we
belong to the
have
northern
perfect.
part of the country.
Yeah.
So, sir,
You are in the
the
northern
ambient,
part.
sorry, means I am from Rajasthan.
Okay,
So,
okay, okay, okay.
in my area, the temperature reaches beyond 50, ambient temperature reaches
Yeah.
beyond 51 degrees centigrade, sir.
Yes.
So,
Yes.
sir,
Yes.
and sir, what about the existing solar modules which we have or our university have? So, what, because, sir, as per your statement, they were producing nil or near to zero efficiency or lesser as compared to when they were performing below 35 degree temperatures.
Yeah,
So,
yeah.
sir, what we can do without
As
putting.
a researcher, what you can do? A very good question. Okay, I can
Yes,
give you a hint like that. Okay, just like I'm a design engineer, most of the time my mind acts like that only. Okay,
yes, sir.
so this problem I'm also facing when I have installed it. Sometimes the temperature results. My area is like hot, super hot, rainy, super rainy. Nothing more than that. No cold, nothing will come here in Mangalore because I am coastal region. Okay, just within 500 meters there is a sea beach. So what I was telling you, when you are in Rajasthan, many solar plants are coming up. If you see 16,000 acre, many if you see good number of solar plants.
Yes, sir.
When I said efficiency not become zero, it drops suddenly by 4 to 5%. Okay, just like if it is giving 16% efficiency, it might be dropped to 12%. The what you are generating, that reduces drastically. Okay, so nowadays what government also feels like that all these things, okay, they have also seen, because many papers are already there, as the temperature raises the efficiency decreases. But
Yes.
as अगर मेरे को as a businessman अगर मैं कोई product देता हूँ तो it is like that my product will work if I am giving you 16 means 16. But traditional has a problem of this, that as that ambient temperature increases till 45, 50, efficiency reduces. Now, how to tackle as an engineer point of view?
Yes.
Okay, we nowadays government are putting one pipelines to put some water. You may have seen in many solar plants now they are putting some water channels like that. Again, what is the loss of water loss is coming. That is also not a good solution. But दे इसका एक दो सॉल्यूशन है. एक तो वो डस्टिंग को भी क्लीन करने के लिए यूज कर रहे हैं, ठीक है, प्लस टेम्परेचर को नॉर्मलाइज करने के लिए भी यूज कर रहे हैं. बट इससे भी हमें उतना बेनिफिट नहीं मिल रहा है. व्हाट द बेनिफिट व्हाट वी आर गेटिंग इज नॉट टू गुड व्हेन वी आर पुटिंग अ नोजल टाइप ऑफ थिंग एंड वी आर स्प्रेइंग वाटर over their solar panels. It is not solving the problem like that. Okay, so another, as a researcher, many of the researchers, just like we are in institutions, we can't do big changes, but many of the paper I have seen, what they are producing fin type of structure behind this on the back side of solar panels, small fins, so that the energy dissipation what we are getting it can be little bit faster as compared to the stuck one. Okay, that is one experimental mini paper. If you see, they are doing it. Many, they are putting some small fans backside like that for release of high temperature, so that your panel will be like, it will give you an increase in small cost, but we are managing with that things like that. But again, the power consumption of that all fans and all, that will again part of it. But
Sir,
if you see the smart flower of Austrian company or what we have developed, one panel is interacting with the other panel like this. Okay, so
yes, sir.
nearby that we have put some sponge and all. Usually every time it used to clean. So that cleaning we have tackled. But for solar, what we are trying to do it little bit more changes with the material type of things. Okay, just
Sir,
like it will not store much radiation and we can do it. So it is in a part of
Dr.
research.
Saurabh,
sir,
Dr. Saurabh.
Austria might not face dust and dirt each and every time, but sir, in
No,
my
no, no.
area,
No, no, no.
we feel
Austria.
so, sir. There we have dust problem, and sir, another thing, sir, water scarcity is also there, sir. So, and sir,
Yeah.
if we will put extended fins, it means we are increasing the surface area for the
No,
heat
no, no.
release.
For heat, yeah, backside of the
Yeah,
panel we
backside,
used to do.
backside.
Yeah, we used to put some extra fin type of structure for that, so that the release of heat will be quite easier to that solar panel. These are
So, sir,
new. देखो ये ऐसा कोई नहीं कि रातों रात इसका कोई solution आ जाएगा. We all are
जी, जी,
doing
जी.
certain small research and we are tweaking little bit and we saw like that, okay, this will be an increment and we write papers. But when you go for the real time, when you put that panel in the real time, okay,
Yes, sir.
manufacturing is another problem to put that panels and other things, because panel itself has a very complicated technology. When I produce our panel now with the help of Madhu, when next lecture will happen, we face lot of problem. Nobody has given us a hand. Okay, you come and you can do laminate of your solar panel and other things. So many problem, many challenges are there while laminating our solar panels. Okay, so that is another challenge. When we say like that, okay, you put fins, you put fans, that will be another challenge. So we are thinking in the material side. Let's hope if some solution we can able to find it out in nearby future research like that.
Thank you very much.
Sir,
Thank you.
hello, sir. Good evening, sir.
Hello. Hello. Good evening, Abdul.
Yeah, sir. Sir, can we get testing facilities, sir, in your lab, sir? So that because
Testing facility means what type of test you want to perform, that is, because NITK has lot of CRF, everything. You go to CRF, many testing facility. What kind of facility you need, you just message me, email me, or related to this project if you want to ask. I can help you.
related to this, sir, because
Yes,
now again from beginning we have to come. It is costly also, private universities.
Yeah. Yes, sir. Yes, sir.
So whatever you told, sir, fins and other things, sir. So that idea we can and collaborate.
देखो, मैं तो ये बोलता हूँ कोलैबोरेटिव रिसर्च इज ऑलवेज यूजफुल, फ्रूटफुल. आओ टेस्ट करो, पैनल पे कुछ फिन्स लगा दो, टेस्ट करके देखो क्या रिजल्ट आ रहा है, या आप अपना डिजाइन कुछ भेज दो, मैं अपने पीएचडी स्टूडेंट्स के साथ क्लब कर दूंगा. दे विल डू सम रिजल्ट, दे फाइंड आउट सम रिजल्ट, एंड इट विल ऑलवेज बी अ फ्रूटफुल फॉर द सोसाइटी. Not for us also, but for society, because the result what we are putting it for societal and industrial purpose. Okay, but right now I am in a product design phase mostly, not only writing paper or something like that, because I have a certain thing in my mind. I want to develop my own venture company, like that, in that mindset. So definitely every industry has to do some R&D. If you see all the solar sector, it is monotonous. None of they want to even touch your idea. They don't want to accept what you are saying in your general papers and other things. They don't want, until and unless China will do something and they can purchase and they can okay, we did it like that, we sell here like that. But none of the Indian industry, that is a wrong comment as a faculty, but what I saw during my this process, that I'm telling you like that.
Any more question from audience side?
Good evening, sir.
Good evening, sir. May I?
Good evening, sir. Am I audible?
Yes,
One by one. Maybe please, Dr. Amar, you can ask, sir, first, then Dr. Manish. Hello, Dr. Amar.
Sir, good evening.
Good evening, sir.
Sir, first of all, I will congratulate you for this such innovative prototype, sir.
Yeah, thank you, sir.
So,
Thank you. You have to
very
give
nice
credit
one.
to my industry partner, InCube R&D also. They helped me a lot. I thank, because as an institutional individual, it is not in my hands also. Fund is there, everything is there, but industry helped me a lot. That.
Sir, related to that, we have also developed, means we are also making a small prototype related to both cleaning as well as cooling.
Yes,
so
sir.
as you
Yes.
have already told, the dust is already there. So
Yes,
we
yes,
are
sir.
recirculating the water and
Yes, sir.
try to recirculate the water so that we can save it. At
Yes,
the
sir.
same time, instead of fins, we are putting some the condenser or something like the heat exchanger.
Heat
We are
exchanger.
putting
Yes, sir.
small pipes so that we allow the water to flow just
Yes, sir.
the under surface of the PV so that we can control the temperature.
Sir, it is also in my part of research. I'm just started this prototyping and testing is going on. So whatever I face, I told you, but definitely it's a very good initiative by you, sir. and whatever the result you can share with us also, we can try
Yes,
with
sir.
our
So
tools also, sir.
yes, sir. In that context, I just want to collaborate with you, or I just
Sure, sir.
want
Sure,
to
sir.
share after this. And
Sure, sir.
another
Sure, sir.
question that, yeah, definitely. So I will take, so I will definitely take this opportunity to collaborate you later on. So I have
Yes,
a
sir.
query, sir, because in previous cases, as you have shown the design, from the
Yes,
design
sir.
point of view, I just want to ask a question that
Yes, sir.
previously we have also used the flip type solar
Yes, sir.
panels. Means the
Yes, sir.
one solar
This
panel.
type of in one axis.
Yeah.
Yes, sir.
So it
Yes,
will
sir. Yes.
be means overlapping another one. When you want, it will be extended so that the surface can be used, and it is also we are putting some tracker so that it will track the maximum
Track the
intensity of
maximum radius.
solar
LDR
radiation.
circuit we used.
Yeah.
Yeah.
Yes, sir. That we have done. But here, my query is, sir, when the as for your design is concerned, is there any
Mhm.
challenge of surface, means one surface over another? Is there any challenge of the damage of the PV surface when it
Uh,
is opened and closed several times?
Till now, it has been developed within this 6 month. We have not faced any scratch or something like that because we have maintained that properly.
Mechanical damage, yes.
Yeah,
That
mechanical damage.
understood.
And we have managed all design and other parameters like that. When you see the Austrian type, I'm telling you what is the difference between Austrian and ours. Our is normal panel. Okay. If you see, we had made it, we have designed it, we have cut it, hands, we have installed everything solar panel by our hands. Okay. When you see the Austrian one, they are very costly. Why they are using backlit solar panel, glass type of solar panel. Okay. So in that case, now they are tinted glass. It means non-scratchable glasses are there. They are using. So the cost of that is very high. Okay. In our case, definitely scratch will place if the proper management is not there. But we have put some sponge, we have given some space, the load management. So every design constraint we have put it. So there is no overlapping right now. Till now, we have not faced any overlapping. Okay. So what? There is a proper distance is there and it is opening it. But only the cleaning area, what it is touching, and it used to clean it, but not the other surfaces over there. Okay. So that's why our panel is still, we have not faced any damage till now. Hello?
Okay,
Uh,
that is a nice one. That is what my
yes, sir.
query. So anyway,
Yes.
sir,
So
once again, I
meaning
congratulate
time
you.
constraint, load calculation, everything, the cantilever, and we
Ah.
did it first manually also. We checked it, everything. Then we go for the manufacturing, sir. Then we manage that. And mechanism also that has been made in such a way that it will not touch. Like,
Okay, anyway, sir, thank you very much, sir. In future, I will
thank you.
just be in touch with you so that
Yes, sir.
I
Sure,
can
sir.
get some more
Sure.
information.
Thank you.
Thank you very much, sir.
Yes, sir. Manish, sir, you are asking something, then Dr. Manish. Sir.
Yes, sir. Good evening. Am I audible to you?
Yes, sir. Good evening, sir.
Sir, first, I want to give a big congratulations to you and your team, sir. This is a
Thank
very
you so much,
nice
sir.
and innovative idea. And
Yes, sir.
I
Thank you
want
so
to
much, sir.
ask few questions related to design. First, you as told about the major advantage of this flower type solar collector
Yes, sir.
regarding the area, base area. Sir,
Base area.
so I want to know what is the major difference between the rectangular as well as your design. And second, I
Yes.
want to know what is the height of flower. Third one, what is the basic mechanism for the opening and closing of the petal. And the fourth one, sir, if we incorporate the behind the petal cleaning mechanism during the opening as well as closing.
Yes, your voice got disconnected, Manish, sir. Last, you are telling.
Last one, I want to incorporate some mechanism for the cleaning purpose
Yeah.
at the back side of the petal.
Yeah. So we also did it, sir. Same thing for cleaning. We have given a small sponge strip that used to always clean that one panel to another like that. It always used to clean it, one small portion. The third question, what you have asked, Nasir, the petal opening and closing. So we are in a urge of patenting it. So I can't disclose it right now, sir. Sorry for that. Okay. Because this is the first stage where I have presented my work. Okay, I'm telling you, even I have not presented, right? 17 and 18, my closer report is there in DST. Okay, I have not presented there also, but sir told me, okay, you give some innovative thing. So I presented here like that. Okay, so sorry for that. I can't give you the exact information about the opening and closing of that. But yes, we have designed our own mechanism to, which is not similar what Austrian company they did it. So patents are available for smart flower. If you like, you will just type in patent. There you can get the mechanism. They used one drag mechanism type of things, but we have not used that mechanism. We have developed our own. Okay. So what was your first question, sir? I forgot a little bit.
Yes, difference between the base area.
Yeah, base
as
area.
compared-
Yeah. With the traditional one. So traditional one, that the rectangular plates, what you see like that. Okay. They used to install in this or as a lengthwise. Correct. So whatever the space taken, it will be a space taken for continuous. There will be, you can't move or something like that. It is non-movable one. But in our case, it is only taking the surface area like that as a vertical. We are keeping battery inside that one chamber. You have seen, maybe you have seen that video, that inside chamber, all the control panels, everything is there. Okay. So only the vertical, what we are saying, vertical and the width of that much space we are taking as per our prototype. Right now, prototype has been developed for 500 watt, but the design, whatever we had made it can be, because we have some financial crunches and limitation. So till 500 watt we have developed it, but that design other below the gear mechanism, it can carry up to 3 kilowatt. Okay, so what area you have taken care for 3 kilowatt, this can be achieved by this mechanism itself. Okay, the height is around 8 feet, 8 to not 8 feet, 10 feet, 10 to 11 feet it is there, sir, right now. But the design, what we have made it, that what we are saying like that in our patent, that okay, whatever the design, it can be also, we can put it a larger panels that can sustain up to 3 kilowatt.
Okay.
Thank you, sir.
Any more question?
Yes, myself, Dr. Sridhar Alaramu.
Yes, sir. Namaste, sir. Doctor.
Yes, sir.
Good evening, sir. Your presentation is excellent.
Thank you so much, sir.
I want to ask you two questions, basic fundamental questions, sir.
Yes, sir.
How much of solar energy in India converted into electrical energy?
Yes, sir.
And that is first question. And second question
Yes.
is, your title is renewable energy.
Yeah.
So what is the difference between green energy, renewable energy, and clean energy?
Okay. So actually, I will give you the exact answer or not, because that is not my area, sir. I'm from mechanical design. So, but I will correlate it, sir. Whatever you have asked, I will correlate it. Okay. So it not might be a correct answer. So if it will not be correct, my apology initially.
What I'm saying,
okay, sir.
Okay. You put the title, it says solar panel, that part is a renewable energy. According to my knowledge, it is a green energy. Solar energy comes under green energy.
Sir, renewable means there are what nature gives us. Okay.
Yes.
Okay. That is mainly our fundamental. But whatever synthetic what we have developed, okay. But the energy what we are using, that is a natural source. The radiation we are not generating. We are only, as a semiconductor, we are just converting it.
Yes,
so it will not, it's a green energy, but we can't say it's a totally a renewable energy. But we are using that renewable sources to convert it. That will be a quite good representative, that we are converting the renewable energy for green purposes. green energy, generation of green energy purposes. That will be a more quieter good title, might be, in my sense.
Actually, according to my knowledge, sir, actually, your title is green energy. Solar energy is 100% green energy.
Green energy, yes.
Green energy has the qualities of renewable energy and clean energy.
Clean energy, yes.
Geothermal energy is a renewable energy and clean energy.
Clean energy, sir. So,
So
that was my apology, sir, because I am not good in that basics. So it might be, but I will take your whatever the good things sir, you are telling. I will note it down, and surely I will change it near my future.
No, sir. Just I too have some confusion because
what you are saying is correct, sir. More technically, thermal people, what they say, it's more correct, sir. What you are saying is.
There is a difference between these three contests: green,
renewable, and
the clean energy.
Clean energy, yes, sir.
The lithium-ion battery it comes under clean energy and not green, because
not green, sir.
Bioenergy comes under renewable energy. It's not
renewable
green
energy.
because
Not
bioenergy generate a lot of smoke.
Yes, sir,
but
yes.
Your solar energy, wind energy, and geothermal energy, they are renewable and clean. That's why you are calling that green energy. But for your topic, your solar energy is a pakka green energy.
Green energy, sir. Yes, yes. You are true, sir.
Whatever knowledge I have, I am sharing with you, sir.
Sure, sir. Thank you so much for enlighten. Actually, I am just a beginner, sir, in this area. So every day I am learning few things.
Exactly, sir. Your presentation is very excellent, sir. I am also beyond that your work only, sir. But other question is, sir, how much of solar energy can be converted to electrical energy in Indian, sir, Indian condition?
That data is not with me as per my knowledge, but right now we are only 3% whatever the energy we are consuming, approximate 3% we have converted till now. We have urged that 3% only we have achieved till now.
Okay. Sir, one more question.
I have not the exact answer with me or exact data, but in my knowledge, it will not more than 2 or 3%, sir, because still we have to go far away. Everywhere, industry, institutional, household, everything we are getting from the thermal energy only, sir, not with the green energy.
As per available data, how much percentage of sun energy can be converted to electricity? See, the literature I'm not finding exactly percentage. That's why I'm asking this question.
Sir, can you pardon, sir? Can you pardon the last question, sir?
How much percentage of solar energy can be converted into electrical energy in Indian conditions?
Indian condition, na, sir. So mostly in a efficiency term, it is not more than 16%, sir. What? 16%, not more than that we have achieved till now. If you are using monocrystalline or that, whatever. देखिए sir, efficiency can be calculated as per whatever the area, surface area you have taken, whatever the radiation. So based on that, for what time it has been. So Indian solar panel, not more than 16%. I have not seen the efficiency of any solar.
You are talking 16, sir? 16%.
Yeah, 16%. Not more than that. The efficiency has been captured till now.
Now, sir, one more question, sir. You have shown a nice, beautiful video. In that, the
last one you are saying, sir?
Last one, just a flower-wise.
Sir. What panel. We have developed a prototype, no, sir?
No. My question is, it's the flower type. The solar panel is moving as per the sun movement.
Sun movement.
It is just like a sunflower.
Yes, sir. Sunflower, sir.
Sunflower also moves like that only as per the sun movement.
Yes, sir. Yes, the same inspiration is taken from there only, sir.
There only. So you use the same sensors which are in sunflower seeds.
Not sunflower is a natural censored thing, sir.
Okay.
We have used, just for your information, we have used LDR circuits, but in a more better way. What people are using, in a more advanced way, we have developed our own a little bit with LDR circuit.
It means it start absorbing sunlight from morning
Morning
7
itself. Morning, yes,
morning 7
yes.
to evening
Yes.
5, 6 like that.
Morning 6:30 something, my area, it enlighten. So within that range, it starts as when it capture at certain amount of intensity, then it captures and it is provoke and it is open what you have saw like that. And evening when that intensity goes down, it will automatically close like that. So we have also put wind sensors. When the wind will be at certain kilometer per hour, it will automatically, it takes the data of wind energy also. So it will automatically close if the wind is very high. Okay. Like that, many sensors are there, sir. That what I have not given because it is in a phase of patent, sir. So I have not given much data of it in this presentation.
Okay, okay. Great, sir. Great answer, sir. Okay.
So thank you so much, sir.
Congratulations, sir. Go with your work, sir. Congratulations, sir.
Thank you so much, sir. Thank you. Your all blessings help me to grow more and more. We all grow like that.
But sir, please consider that green word, sir. Green energy word, please.
Yeah.
In future.
Betty, and I will submit when I will submit to Abhishek sir as a green energy like that, sir. Not
Thank you. Right.
so much, sir.
So is there any question or can I call it a day?
Dheeraj and Purvi.
I have a question. Can I
Purvi
ask?
Chandra?
Yes, sir.
Yeah, sure.
Sir, good evening. Good evening, sir. This is Purvi Chandra from GIFT Autonomous Muneshwar. Sir, my
Yes.
question is that what you have shown in your last video, it is a like movable floral solar panel, right?
Yes.
And you said that it is not, it is a new product and you have not been like you have not installed it anywhere else. And this is a like that is
We
the
have
novelty
installed
of
in
this
our
product.
NITK, madam. We have installed in our testing phase is going on, madam. Right.
Okay, but I have seen some kind of like this floral solar panels somewhere in Raipur only. So is it something different from that, or it is the same thing?
Madam, if you can share the photos, because still up to my literature review and my knowledge, in India nobody has developed till now the smart flower in India. But whatever the same smart flower has been Austrian company, that was my inspiration in 2018 when I saw, I liked it, I took the inspiration, but it was so costly and I want to do the re-engineering in that, but that was not feasible because Indian government has a policy, you can't purchase something or Austrian company, they have not agreed to give us, so that option got lost and we have developed by our own.
Okay.
So we have I don't know where you have seen, but if you share it will be kind to us.
I'll surely share, maybe because while going in the road I just it caught my attention. So when I saw your product, I could really relate to that one. And my second question is that, is it possible this kind of solar flower you are going to install in for office project or something like that? But is it possible to install a miniature of this flower in for domestic use?
Yeah, surely, madam. We are our main target is consumers only, na, domestic consumers. But right now the product is in prototype phase, na. So this prototype, with that prototype, we can generate some fund for our business. We will target as a where government. Okay, so that they will give little bit fund, and when the production raises, definitely the cost will reduce. It will reach to the common people also, ma'am.
And for that, do you need the same kind of infrastructure, or we can reduce the size of the plates?
Yeah,
right?
madam, it depends on what kind of, just like I will give you an example like that. Smart flower, what they do, they built a 3 kilowatt, 2.5 kilowatt power generated smart flower. They used to develop 3.3. They used to develop for 4-5 kilowatt as per your requirement. You have to only tell them, they will, because main jo iska crux, what I say of this design is below the petals. below the petals, the
Okay.
mechanism. Okay. Once
Okay.
if you are able to develop that thing, many changes you can do it, many wonders you can do it with
Right.
3 kilowatt,
Right.
whatever you want. Okay. As
Oh,
design constant, as a design, there we used to load calculation, damage and everything we used to find it out.
okay. Thank you, sir. Thank you so much. I must say,
Thank you, ma'am.
this is one of the
Namaste.
most insightful presentation, and I'm really
Thank you,
grateful
ma'am.
that you choose this topic, and all the very best.
Thank you,
We wish
ma'am.
you that
All your loves are
your
there, so we
product
are
will be
doing it.
selected, and we will get the benefit out of it. Thank you so much, sir.
Everybody, ma'am. Thank you so much, ma'am. Thank you.
So thank you, Dr. Saurabh, for very wonderful and interactive session. So again, anyone, Mr. Ramaswamy, you want any question?
Yes, sir. Good evening, sir. This is Valarmati Ramasamy from Coimbatore.
Yes,
Yes.
ma'am. Good evening.
Good evening, sir. So, I've seen that your prototype model.
Yeah.
And is there any enzymes can be used as the lotus leaves, as this when water it is dropped over, that enzymes can be used to remove the dust, sir? Is it possible to undergo such thing?
Ma'am, very beautiful things from the chemical. Might be you have a very good knowledge in that chemical engineering,
Yes,
and
sir.
we
I'm
love
a
to put
chemistry
it.
faculty only.
Yeah, ma'am. Once you asked the question, I understood, ma'am, and it's very beautiful suggestion, ma'am. And what I told you now, that many material property changes we want to do it, but just right now I am in a place where fund is the main constraint. But what you are
Okay, sir.
saying now, if you can develop some spray or something like that, okay,
Okay,
that's
sir.
chemical, okay, that we can put it permanently solution to the tempered glass, or you can generate some anti-dust chemicals or something. We can use it for traditional also to increase the efficiency,
Okay.
what we are getting. So it's a beautiful idea, madam, as a material point of view, and I'm also agreeing, as per my knowledge, it will be a beautiful solution. But I don't have so much capability in that chemical area, so I can't
Okay,
develop. But if you do so, I will definitely experiment in my pen.
Okay, sir. Okay, sir.
It is
And
possible,
because
madam. It is possible that.
yes, because so it should be whenever the chemical is used, it should not create any, it should not release any pollution or the
Yeah,
pollutant
ma'am.
into the environment.
Yeah,
So
ma'am.
in that fact also we have to consider.
That we have to actually, ma'am, when you are saying algae and all, na, when the algae decompose it depends on which kind of
Yes, sir.
algae it is. Okay, it might
Hmm.
some dots, maybe they leave it out, or sometimes they decompose it without transparent also. So we have to search it out which kind of that algae we can use it, so it will not create any other pollutant to that area. Because here the transparency
Okay.
of the glass plays a vital role in the efficiency area, ma'am.
Yes, sir. That. Okay, sir. So whenever the dust falls on,
Yeah, ma'am.
This chemical, that means it may be organic nature product. So we
Yes,
have to
ma'am.
search on such type of the thing to remove the
Yes,
dust.
ma'am.
Okay, sir.
Yeah,
So
yeah,
that will
sure,
be
ma'am.
gone in their research only, sir.
Yeah, ma'am. Surely, I agree, ma'am. These are the many. It means if you see the solar panel as a common people, it looks like a solar panel. But when you
Yes.
go as a researcher, na, every
Yes, sir.
panel, every layer has a point where we can do the research. Just like for
Yes, sir.
thermal people, I told you now that temperature is one of the specific
One of
area
the-
we can search it out. Even semiconductor has a material science.
Yes,
Many
sir.
right now advancement in different semiconductors is going on. Even in the glass itself, tinted glass, even what smart flower they are using, that is even glass itself they have put in. They have not any solar panel aluminum surface. It itself is a glass. Inside that solar panel is there, sir. There, madam. So lot of research has already been done, but what you suggested, that also we can implement, and we can see what are the effects in that. So it's
Okay, sir.
definitely you can purchase a small solar panel, you keep it, when dust comes you spray it, and you can check it at what is the effects in that glass. You can note it down and you can present as a work, man. That will also a very
Okay.
good publishable work for
Okay,
glass
sir.
industries.
Okay, sir. Okay, sir. Your presentation is very good and very informative, sir.
Thank you, ma'am. Thank you.
Thank you. Thank you, sir. Thank you so much.
Okay. Thank you. So, any
Some,
other question?
Sir, some question in chat box also. Salesh Matri has asked, how can we increase the capacity of light trapper and detector in case of mono or multi-polar panels?
So I am a little bit apology to that, madam. I am not in that background, madam. So the light emitting and other researches can be done by material people, semiconductor people.
Yes, sir.
So
This
I
is my
also
question.
don't know much about it, madam.
No, sir. This is my question. So, how to increase the light detector capacity? So, no, it is not your but I can get it from.
Actually, Saleji, what
Yes.
for capturing maximum intensity as a design perspective, what we have done it like that azimuth angle and all such things, that is one parameter. Okay, another parameter is because this is a global parameter, okay, that I have to take it anyhow. Okay, another parameter what we took it is as what if you see the panel has been absorbing the LDR radiations. So where I can keep and what is the maximum intensity it will capture, that is the basic importance in this design. Okay. But as a material point of view, I don't have much knowledge, Salesh. Thank you, sir.
Very nice
and another question is that solar panel open automatically, or
yes, sir,
is it any remote control system to open?
No, nothing. No remote is there. It's fully automatic. The control system has been designed such a way everything is automatic.
And Sir Rohan has asked, as my college is just around a kilometer from NITK, can we come to see this system?
Yeah, sure. Very warm welcome. Please come to NITK. Yeah, actually, the problem I have not till now I have not patented it, and the problem is we have not showcased anywhere till now. This is my first platform due to Abhishek. I have just presented. Madhu will come. He will also maybe Madhu has joined. I don't know. His session started at 7:30. So
I'm here.
Hey, hi Madhu.
Second
How are
session
you?
is yes, sir.
Yeah,
Hello, sir.
and I thanks a lot my dearest Madhu every time. Okay, so today this platform we have a small showcase we did it, but without Madhu it is not possible. As an industrialist person, he is one of the scientists who do lot of many research. You can get a lot of knowledge in his presentation.
So
yeah, please
now
whoever wants to come, please
our next
come
speaker
and
is also
see
here.
them.
Yes, sir. So I am very much thankful to Dr. Saurabh Chandraker for very informative session. And apart from that, I'm also very much thankful to all the participants for from morning to evening. You are spending time at college, and now you are all are present here and such a giving interactive response in this session. So I am thanks to the speaker as well as to the participant. Now I think it is a continuous session. So everyone can take 10 minutes tea break, and next session we will start after 10 minutes at 7:50 we will start. Our speaker is also here. So we are closing this meeting for 10 minutes, and after 10 minutes again we will start the sixth session. Thank you.
And thank you
Dr.
everyone.
Thank
for
you,
such
sir.
a patience.
Sir,
and
in the chat box, there are lots of appreciation messages for
yeah,
you, sir.
thank you so much, sir. Thank you. I will read it out.